All right. Hello.
Сейчас я сегодня продолжу тему
I would like to continue this change validation topic. I would like to extend it a little bit. We'll speak about using the topology, how we not only take into account the topology, but also talk about
как проверять, что, например, в сети нет
how to validate that there are no devices with the similar host names, make sure that all of them have the same MTU, and we'll speak about our approach and what we've done and where we're going to. This presentation has a bit of a dacha flair, and in our dacha will be
немножко обо мне.
Trying to eliminate
занимаюсь автоматизацией разных крупных корпоративных операторских сетей.
And I'm Dmitry Larin, and I'm specializing in larger solutions, and I'm a CEO of the Huddle company. So what would be the validation of changes? In the network, there are plenty of changes that require control. That's the configuration, whether we meet the golden config templates, the condition of the devices and the protocols. Here we see that the session is not down. We keep up the devices, check for their uptime. And in terms of security, we make sure that we validate that it meets the best practices of security. Why would we always need a permanent control? There are three reasons. First of all, we just need to maintain the hygiene of the network. So you actually detect the violations at very early stages before they influence your infrastructure. Thus, you control all of the changes introduced by network engineers. So the second benefit you get from hygiene is that you don't have any sudden situations with troubleshooting. They're all the same, typical, and you just check and verify them. And the engineers know what they work with. Automation is the next thing. We've done automation for a number of years. So we say that if you automate chaos, you get automated chaos in the long run. If we have configurations for different services like DXLAN,
то есть, опять-таки, вам нужно выровнять все конфигурации по всем устройствам, да, и
you need to set the same configuration on all of the devices and then automate it. And number three is safety. You control all of the devices, you know which is which, what are the versions of the operating systems, where you have users, so you may maintain security. So basically, this is a simple task to understand, which is very difficult to implement, as far as you can see. First of all, it's due to the size of the infrastructure. The larger the infrastructure and the more the vendors' equipment is used, the more heterogeneous it is, the more difficult it is to validate it. Next, we should say, get some kind of data. How do we do it? Other interfaces provide us through NetConf, for instance, or GNMI. We're talking about the Russian vendors, and if we talk about Western vendors, they are secondary. So the main interface which we can use to get maximum of the information is the console interface. Using large language models here cannot be a suitable solution for the configuration, because we need to use this with particular configurations, and it may work on Western vendors, but it doesn't work with the Russian vendors' equipment. We tested that. So the only way to do the validation is to collect the
нормализовывать датасет, обрабатывать
SSH command output parse unstructured text, normalize dataset and process. Here is a quick example. We're talking about the status of the interfaces. There are two vendors. One of them runs two commands just to check the status. Another one just needs one command to run. In actual fact, you need to write a parser for each command, for each operating system, etc. All this work should be done by engineers. One of our customers once said, and he wanted and needed to validate a number of changes in the network, so they could have singled out a person who could have collected the data, who could collect the data and find the information. So it was the data gathering and parsing. This is the work which is very boring. And that's why it makes the engineers suffer. In most of the cases, this is not a task that can be resolved completely. Because all these tasks are put on the shoulders of the engineers, and the engineers are not developers, and apart from validation, they've got different other operating tasks. So we've encountered this task, and we ask ourselves a question: how could we simplify the task to just one inquiry? So we'd not write the parsers, how would simplify the work with the data and make an inquiry saying what's wrong. So we did exactly that, and then I'll explain what we achieved. I would like to start with the definition of what needs to be validated.
Масса, соответственно, людей начинает, компаний, соответственно, команд.
Most of the people start with configuration. That's the golden config. Best thing that we can do. We can assemble the config, check the settings using the specific tools, checking the data, checking the format, etc. The second thing, which happens more rarely, is the operational status validation. So it's the device states and protocol states. For example, it looks for recent reboots, OS versions, port statuses. Or, for example, here for protocol status, it's RIB, FIB, BGP, OSPF, STP, LLDP. Here we are talking about session states and the devices with near neighbors. There are many parameters. And thirdly, this end-to-end network behavior. We take the network as a whole, which sends traffic from A to B, and we need to make sure that there is a route between A to B. There are backup paths, there are backup routes, there are no loops, and we would like to control and monitor it a few times a day. The second verification tool is the zone demarcation. So we just take a look at the network and check the routing, and
я о нем рассказывал подробно на NextHop в
connectivity. I would not elaborate on this. I spoke about it at NextHop in 2024. We spoke more in detail about the math we use for verification of traffic paths. So we are going back to data nesting. So what we need to consider, data nesting certainly being one of these things. We just take a look at a template, we use regular expression, and we check for the presence or absence of configuration lines, strings rather. And later on, they come up with configuration checkups. The checks and checkups must be used and used correspondingly. For example, if you have a VLAN, VLAN should use such and such ports. It may come up with lots of examples of networking. So, as we implement the validation methods, we need to take into account the functional checks. Moving on. We need to take into account the so-called topological connectivity, because most of the checkups are about network topology, MTU and duplex on adjacent ports. When we speak about the routes and the routing table, and make sure that you have LLDP disabled at the network edge, you need to make sure you understand not just the configuration, but the exact devices working together and how they are interconnected. That's why you're taking into account not just the physical connectivity, but also the logical one.
Окей. Дальше, что нужно учитывать от изменений во времени?
We need to take into account the time changes, changes over time rather. So, for example, everything works, but then something breaks down, and now ago everything was fine. What happened? You need to make sure that you know the time when it happened. And we said that we have devices, network, we have the topology, and why not use these data not just for checks, but use this for random samples. We can get a query or which ports the VLANs are configured, what are the access ports configured, at which ports exactly. So we're talking about the inquiries to the network to make random samples. I've done with the theory part. Now we will speak about the actual implementation. I'll speak about the two types of approach, the first attempt and the second attempt, where we had our lessons learned. The first type of approach is the head-on solution, as we call it. We did the we execute show commands via SSH, collect the outputs. The validation was a set of regular expressions, so we made sure that there are some points present in command output or not, so the user would get the result, a set of devices that passed or failed the test. What are the advantages of this approach? It's a very simple one in implementation. Later on we'll speak about its deficiencies. You just need to set the command and have regular expressions which check for presence or absence of such and such strings. It is suitable for simple tasks. But there are some disadvantages here and flaws, and there are way too many. There are no functional checks, for instance, if, then, else. You can do the random selections, but you always need to write regular expressions, and an engineer needs to create a template for that and identify what needs to be configured and what should not.
Okay, so this approach was not scaled. So we started rethinking our task, and I'll tell you first our stream of thought of the desired outcome. So we have some non-structured or unstructured data, an array of commands. On the second phase, we want to normalize, to get normalized data. We want to have a vendor-independent view with which we would like to work in the future, and will be convenient. What I mean, we will be sending queries to this data, and then we will get a list of users, a list of interfaces which has descriptions or have not descriptions. This is a very simple example, of course. So how to implement all of this? In theory, it seems that it's all very simple. We have the data, we've parsed them, we implemented them, and then we've created a language of queries that will allow us to get this data. But in practice, there are a lot of challenges on each phase of its implementation. So let's start from the beginning, from data collection. From the point of view of data collections, we have all the challenges that you can have. The great vendors took care of us, they wrote everything, but some device can crash, right? Some devices can provide data with certain intervals, right? The number of different connections, types of connections, so on and so forth. When you click show shrunk running config and you put space, yeah, this is actually a very simple scenario. Yeah, there are others, wonderful scenarios. Yeah, the vendor's ingenuity can amaze, really, sometimes. This is just the tip of the iceberg. We have these peculiarities all the time, so every box that we add has its own nuances. The second phase is the data parsing. So we speak from experience here. We support 19 different vendors, 23 different operating systems. 68 versions of operating systems. Nexus alone has 120,000 variants of setting the valid command of configuration. So we have to deal with this somehow. And our recommendation, and again, if you want to implement a task like that, is to simplify, maximally simplify the parsing of outgoing commands. Tell it to your developers. So parsing of data is one of the major tools that we can use here. Let's continue. Normalization. The normalization process is nothing but structuring data, giving it a structural format and view that doesn't depend on anything else. So everything we've collected, everything we've parsed, we try to put into an independent model. We use YANK model OpenConfig plus IETF as a model. Why? Because this is a preset schedule for config state. Why do we use both? Because each of them has parts which others lack. That's why we use both of them. So what do we do with these YANK models? We simplify the schemes for read-only mode and add the topology to it. So we take the best from both worlds, so to speak. So let's talk about the query language and the query engine. Let's start with the data model. The data model is represented as a tree. So all the parsing becomes a tree-like structure, at the root of which lies the network. Inside there is devices, and inside each device there are lots of interfaces. So the basic thought here is that this model is built along the YANK tree, and in order to work with the model, we use the language query. We use Python as the query language. Why? Because it is mostly the most widespread language of network engineers. And here you can use LLM to generate the code. This is one of the directions in which we're going. So basically, you can send the queries such as, write to me the code that will get to a specific VLAN, okay? You can use this code in order to check the validity of your assumptions. So LLM can do that because it knows Python. So here you work with data. data. The user works with data with JSON. This is the script example that allows you to get information from all devices that have not been configured description-wise. Okay, so we want to check the description of a specific device if its status is up. As a result of this query, the user gets a table. He sets his own basically themes of testing, and you can do that also for the sampling as well. This is a slide with the result. Again, there is a code that the user writes in the interface. Then he presses the execute button, and as a result, you get a structured data table. And yet, as another example, here you see the script of all devices which have VLAN 10. Because we work now with structured and normalized data, this query only takes 13 strings, okay, given to spaces. What I want to say that it's very easy to write queries and check the network for its configuration topology. So this is how the validation process is built. Okay, initially, engineer was involved on each phase, starting with integration and processing, and finally we simplified this process. An engineer only works with the logic of data processing. An engineer only writes microscripts on Python and interprets the results that he gets. So all of the boring stuff, we took away all of the boring stuff. The engineers are happy and become developers. So let's talk about possible scenarios of use. I'm describing here the process which we use. So an architect sets the rules for the network from the point of view of validation and verification, the way it used to be. So engineers do their stuff, they introduce the changes. Each change is checked for the rules. If it adheres to the rules, okay, engineer continues his work. If it doesn't adhere to the rules, then we form the list of variations and we ask ourselves, is this a transgression or not? If it is a transgression, then the query goes back to the architect. And if it's not, then we try to get rid of it. Another scenario, which we expanded a little bit in terms of its use, that is for automated care of the errors. So there is an interface and a neighbor. Let's say these ports don't have descriptions. Because we process this in Python, we can create a template and put any needed values into it. We can create a separate column for it, and then this data has to be deployed on the device of any system.
Okay. И еще один сценарий рассмотрим. Это
another scenario.
Собственно, при импортозамещении тоже один из
using the samples
заказчиков в том числе.
Это
значит, тут сценарий применения 2. Это снижение расходов.
Import sustainability. So there are two scenarios. When you buy new equipment, since you're doing the sampling, you can understand how many ports are busy, which characteristics you have to take into account, and to check whether you can indeed decrease the equipment that you want to buy. It's also the validation of busy devices, the devices that you use at the time. You check a box of a foreign vendor, and you see that it's only one active path, so you don't have to buy an extra box. So this is the first scenario. And the second scenario is confirming the requirements to the hardware. So basically you can check and validate that you really ask from the vendors everything that you need for the infrastructure. By doing this, you will check yourselves first, and secondly, you will decrease the demands for the vendor. So let's let's draw some conclusions. So validation consists of checking configuration, checking the operational state, and checking end-to-end behavior of the network. You have to take into account the functional tests, topological connectivity, changes in time, and as a result, you will have the validation of changes, you will have the random sampling opportunity, and you will have a retrospective view of how all of this was changing. Let's go forward with the validation. Validation is a continuous process of dataset expansion. It's researching the ways to simplify the queries language. It's a chatbot, if you will. And finally, we research the methods of automated specification of the network involving the machine learning with the use of patterns and templates that exist in the network and which we control with Go and configure. By way of conclusion, please, validation can be tested. You can join our Telegram channel. And the second direction that we have in the company, we have an R&D lab in FISTech. So we research complex R&D tasks, and we would be happy to share our experience. If you want to rate my presentation, please use the QR code on the screen. Dmitry, thank you very much. Oh, I see there are lots of questions right away. This is the book as a price. I have two questions. The first is simple. How does your system discover the networks? Is SSH access enough or not? And how does your system know the list of devices? Do you have to mention VLAN and addresses? So then it's very easy. You just draw the structure of the network, and the program has to write the host names. In other words, do you automate this? And the second question, can your system minimize the firewall rules? Okay, let's say it has its config as USG. It can contain up to 1 million strings. In order to find the crossing strings, kind of redundant strings, can it simplify it and make it twice as small? How do we collect data was the first question, right? Okay. Yes, we do use SSH, so we connect to devices. We only execute show commands. There is a set of these commands. We do not go into the config mode, right? We go into the network. How do we scan it? There is a number of ways to do that. You either set the addresses right away that you're going to check, or through sub-networks, and then we look for each address of this sub-network. Based on these addresses, we build the topology. Well, not so much the topology, but the report, because it's for topology, right? This is a multi-level topology that has several protocols. Can you also visualize the commutators? Okay, what about firewalls? Yeah, this is one of the scenarios. It does work. As far as the second question about the firewall rules optimization, yes, this is one of the tasks that we're trying to solve. Please talk to me. So you've done that and it's working? Yes, we've done it and it works. It's mathematics. It's not the mathematics that I've talked right now. It's a little bit more complicated. But you don't have a firewall presentation, do you? No, I don't have a firewall presentation. Okay, well then maybe during the next event, you'll give us a firewall presentation. Yeah, including the positives, name of the company, firewall support. Well, Dmitry, thank you very much. Since we only had one person. Oh, no, sorry, there's another person. I have two questions. Look, you said that there was a way to optimize infra by buying cheaper equipment, but the business either grows or dies. Did you take into account any reserves, any increase of traffic or business? Yes, of course, we did take that into account. And again, if you want, approach me in the corridor, so to speak. Yes, sir. So what's the percent of the reserve that you put into that? Okay, let's talk privately about that. And another question about the feature set. The feature set can be as big as whoever writes it can make it, but it doesn't always correspond to the truth. Some features can work in a very limited set of conditions. Thank you. This is a very good question. I think what we are dealing with here more is this. A customer had a segment, and the customer knew that it needs specific technology for this specific segment, and it was working well. So we use it across the board in our network, and then provide this requirement. But it was discovered after R&D, right, of what is configured, what is not configured. It was discovered that this technology is not used in at least half of the network. So for the half of the vendor, you can use another vendor which doesn't have this technology, which is cheaper, and then you economize on equipment. Okay, so you don't use it? No, we don't use it, and we don't plan to use it. Thank you. Okay. All right, if there are no more questions, then Dmitry, thank you.